Hello class, today we're going to talk about section 9.6, which is exponential functions. By the end of today's lesson, you will be able to graph exponential functions, solve exponential functions, and identify the difference between exponential functions and linear functions. An exponential function is a function where the base is a constant number and the exponent is the variable. So if you look at the equation, we've got y is equal to ab to the x power, where a can't equal 0, b has to be greater than 0, and b cannot equal 1. So to break down what this means a little bit, so for example, I could have y is equal to 3 in parentheses negative 2 to the x power, or I could have y is equal to 7 to the x power. Difference between these two. In this first one, there is an a value and the b base value. So the 3 is outside of the parentheses and that negative 2 is inside the parentheses because that's what has the exponent. Down here, there technically is still those two values. It's just that this time, that a value in the front would be negative 1. So sometimes you're going to see it with two numbers. The exponent only goes with the second number. Sometimes you are only going to see it with one number. So for example, we have y is equal to 3 to the x power. When we go ahead and graph this, we are going to do so by creating an xy table. We're going to use negative 2, negative 1, 0, 1, and 2 as those values that we are plugging in. When you type this into the calculator, you would do 3 caret negative 2 for that first one. And that's going to give you an answer of 0.1 repeating. We're just going to round it 2 decimal places, so 0.11. For the next one, you would do 3 to the negative first power, which is 0.33 repeating. Again, 2 decimal places. 3 to the 0 power is going to give us 1. 3 to the first is going to give us 3, and 3 to the second is 9. So again, when you type that into the calculator, you are using that caret button, which is the 5th button up on the left if you are using the calculators that we have at school. We're going to go ahead and put this on the graph now. So I've got negative 2 at 0.1, negative 1 at 0.3, 0, 1, 1, 3, and 2, 9. When we graph this function, if I continued, for example, and plugged in negative 3, I'm going to get an answer of 0.04 after rounding. So that negative 3 value would again be right there. Exponential functions have this tail at the bottom and then curve up quickly. So this bottom tail part is just going to be a flat line. It is going to approach the bottom value, but it will never touch it. So that's when we get into the domain and the range. In this case, domain, just like our quadratics, is all real numbers. I can plug anything in for x. In this case, the range, we could keep plugging in negative x values and we'd be getting closer and closer to 0, but this function will never actually touch 0. So y is going to be greater than 0. If our function curved the other way, so curved down, y would be less than 0. So it's going to depend up or down if it's getting greater than or less than that value. Y-intercept, we find like we always do, looking where it hits the y-axis. In this case, we are hitting at the point 0, positive 1. So that y-intercept point is at 0, 1. And then the last thing your book is going to ask you to do is to plug in one more random value. So you're going to type into your calculator 3 to the 1.5 power, and that is going to give you an answer of 5.20 after rounding. So it's just giving you a chance to practice plugging in one more. Couple things that I want to note. Some of your exponential functions are going to be fractions. When they are fractions, it is crucial that when you plug them into your calculator for that XY table, that you put that fraction into parentheses. So it's going to be 1 divided by 3, close the parentheses, and then the caret. If, for example, we had the function 4 and then 1/3 to the x power, you're going to do 4 and then in parentheses 1/3 caret and then whatever number you're plugging in. So when there are parentheses given in that problem, those parentheses need to be typed into the calculator as well. This would work the same even if it wasn't a fraction. So if it was 4 and then x to the second, we would still, when we typed into the calculator, leave those parentheses around the 2, but not around the 4. So that's just a quick note on typing things into the calculator. So for the second one, we are going to plug in 1/3 to the negative second power, and that's going to give us 9. 1/3 to the negative first power is 3. 1/3 to the 0 power is 1. 1/3 to the 1 power, or to the first power, is 0.33. And 1/3 to the second power is 0.11. I'm going to go ahead and graph these points again. So I've got -2, 9, 1, -1, 3, 0, 1, and then we've got our points at the end. Again, it is going to be curving and have that flat line at the bottom. So in this case, our flat line is coming from the right and then going up. Our domain, still all real numbers. Range in this case, again, is going to be y is greater than 0. All of our y values are getting greater than 0. Notice how in both of them I don't put the equal to part. It will never actually equal 0. Then we're looking for our y-intercept, which again in this case is going to be 0, 1. And we're looking for 1/3 to the 0.3 power for our last value, and that gives me an answer of 0.72 after rounding. Go ahead and try this one on your own. So in this case, when you are plugging this into the calculator, you would have typed -3 and then in parentheses 9 caret and then whatever number you were plugging in. You can see those values in the table. Our domain is still all real numbers. Our range in this case, y is getting less than 0, so we're getting smaller. Our y-intercept is 0, -3, and plugging in that bonus point, we get -4.66 after rounding. Other things we're going to have to do is be able to solve these exponential functions. So a certain bacteria population doubles every 20 minutes, beginning with 10 cells in a culture. That's where they keep cells when they're studying bacteria. The population can be represented by the function b is equal to 10, and then in parentheses 2 to the t power, where b is the number of bacteria cells and t is the time in 20-minute increments. How many will there be after 2 hours? One key thing to pay attention to here is what they give you for a time span. In this case, we're looking at 20-minute increments. So we are not using our 2-hour value. 2 hours gets split up into 120 minutes. 2 60-minute period is 120. We are cutting those into 20-minute chunks, which is going to give us 6. So we have 6 separate time frames that we are looking at. Some of the other problems will give you a starting year. So for example, years since 1990, and then we'll give you 2017, and you would have to go back and calculate the difference between 1990 and 2017, which would be 27 years. So a lot of these problems with exponential functions, you have to be careful with what you are plugging in for your t value. So then once we have our t, it's very simple, and we just plug into the equation. So 10 times 2 to the 6th power, which is going to give us an answer of 640 bacteria cells in that 2-hour time span. Go ahead and try this one on your own. So again, paying attention, we started at the year 2000. We're looking at 2005. That is a 5-year time difference. So we're going to go ahead and plug 5 in for the exponent, which gives us 206.50 billion liters for our answer. Last thing we're going to want to be able to do is identify exponential functions based on graphing or based on the table. So we're going to go ahead and look at our table that they give us. Those values will not fit on the graph as written, so I'm going to go ahead and renumber. I'm going to count up by 8, so 8, 16, 24, 32, 40, 48, 56, 64, 72, and 80. And then going across does not fit either, so I'm going to count by 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I'm going to go ahead and graph the points starting with 0, 64, 5, 32, 10, 16, 15, 8, 24, 25, 2. If I look then and connect these points, they are going in a curve, which is going to indicate to you that this is an exponential function. So you're going to graph the points and look for that curve. Other things you might want to look for. So we've got an exponential function here. If it gives you a table and it gives you that U shape, remember that that is a quadratic function. If it gives you a table and it gives you a straight line, remember that is a linear function. So those are the ones we are on the lookout for when it's asking us to identify if it is exponential or not. Go ahead and try this one on your own. In this case, after I renumber the graph and plot those points, my points are going to end up in a straight line, so it is a linear function and not an exponential function. If you have questions about this or anything else from the lesson, please let me know when you get to class.